Hello. Continuing our work on factoring, let's take a look at difference of cubes, how to recognize it, how to use the formula, and what happens when after you factor your difference of cubes, you find you actually still have more factoring to do. Let's go. So I know this video was called difference of cubes, but bonus, I'm going to show you sum of cubes and difference of cubes. Okay, so this is a great place for a screenshot. Here are the two equations of how you factor a sum of cubes, meaning addition, or a difference of cubes, meaning subtraction. Now, let's take a look at some patterns so that you can remember these more easily. So the first thing I'd like you to note is that the first term of each of these just uses the cube roots of each of your initial terms, and it repeats the sign of both of your initial terms. So the next thing I would like you to notice is that the next term looks an awful lot like your perfect square quadratic, right? Which is f squared plus or minus 2f times g plus g squared, only it removes the 2. And then the next thing I would like you to notice is that this time the initial sign here is different than your initial sign there, but that this last sign is always positive. Okay, so this is another great place for a screenshot. And now we're going to go ahead and apply this to two different cases. One, a sum of cubes. The next, a difference of cubes. And stay tuned for this one because there's further factoring to do sometimes with the difference of cubes. So here's the first problem we're going to work with. A cubed plus 8b cubed. The first thing to check out is this a sum or a difference of cubes? Well, we've got no middle terms, right? Our two terms only. A cubed, that is something times itself 3 times. And 8b cubed, again, that is something times itself 3 times. So yes, this is a sum of cubes. So the next thing I like to do is write out my formula. And my next little hack, just to make life easier, is I like to then figure out, okay, what is my f? What is my g? In other words, what are the cube roots of each of these elements? So I would, on the side, do this. F equals the cube root of a cubed, and the cube root of something cubed is always itself. So in this case, my f is a. And then g equals the cube root of 8 times b cubed, which can be separated into the cube root of 8 times the cube root of b cubed. Well, we said the cube root of anything cubed is itself, and I know my 8 can be broken down into 2 times 2 times 2, and 3 of anything on the inside of a cube root becomes 1 on the outside, so that simplifies just to 2b. And now I've got the elements that I can substitute into my formula. So that would look like this. My first term is f plus g, so that becomes a plus 2b. And my next term is f squared, so that's my a squared, minus f times g, so that's my a times 2b, so that's 2ab. And then finally my g squared, so that's 2b squared. Well, don't forget to apply that squared to both of those, so that becomes plus 4b squared. And that is as far as this can factor. Okay, now keep watching because here comes the one that has the added trick. Teachers love to put this problem on tests. Okay, 64x to the 6th minus y to the 6th. Okay, is this a difference of cubes? Well, again, we only have 2 terms, so cool. 64, that is something cubed, that's 4 cubed. 8 to the 6th, that is something cubed. We'll look at that in a second. And same thing, y to the 6th. Okay, so again, let's write our formula. Let's figure out our f and g. All right, there's my formula. Let's find our f and g. F is the cube root of 64x to the 6th, which can be separated into, and 64 can be rewritten as 4 times 4 times 4. If you didn't recognize that, you can always do a factor tree and wind up with a whole bunch of 2's and pull those out 3 at a time, because remember, 3 on the inside yields 1 on the outside, so that turns into just 4. And now, here's how I like to deal with roots of exponents, I like to take my root and re-represent it as a fractional exponent. So that would look like this. The power of the exponent is the numerator of your fraction. The power of the root is the denominator of your fraction. So I would rewrite it like this, right? There's the power of my exponent as the numerator, the power of my root as the denominator, and 6/3 is just x squared, and that maps out because x squared times x squared times x squared, right, times itself 3 times is x to the 6th. So my f is simply 4x squared. And now let's do it again with our g. So the cube root of g to the 6th, I take those and make them a fraction. My exponent becomes my numerator. Power of my root becomes my denominator, which simplifies to y squared. So now I can substitute these into my formula. So here I go. First term, 4x squared minus y squared. Second term, 16x to the 4th. Don't forget to square both of those terms, plus 4x squared y squared plus y to the 4th. Now, am I done? When you have a difference of cubes, you want to check that first term because it could be a difference of squares, and in fact it is, right? You don't have to with the sum, because a sum of squares, that is a complex factoring. So generally you leave that, that's its simplest form. And by complex, I mean imaginary numbers, not difficult. But for difference, you could end up with the difference of squares, and we do. So if you haven't watched my video on difference of squares, check this out. But if you have, then you know that this further factors into 2x plus y times 2x minus y, and then we still have the remainder of our difference of cubes, and that is the full factorization of 64x to the 6th minus y to the 6th. Okay, have fun practicing the use of those formulas. Do take a look at the difference of squares video if you haven't. Feel free in the comments to leave me any factoring problems or topics that you'd like me to make a video on to help you clarify. And as always, keep on mathing.